Welcome to the Databricks Skill Builder series. We're glad you're here.
Good morning, everyone. This is Jyotsna Bharadwaj. I'm a solutions architect at Databricks. And as part of today's session, what we are going to do is we will discuss the capabilities in our platform around AutoML. So the agenda which I was planning for today was, let's first just talk about what AutoML is. And we are talking in context of traditional ML, your classification models, regression models, forecasting models, so on and so forth, right? I know there's a lot of buzz around Gen AI, but then the traditional machine learning has its own place. It has a lot of importance, and a lot of our customers are leveraging traditional ML to optimize and predict a lot of their work. So after that, we will talk about how it works, and then I would try to walk you through a demo of how the AutoML offering of Databricks works. So having said that, so let's first talk about what is AutoML. So AutoML, automated machine learning. What this helps in, or what it does, is that it fully automates the entire model development solution so that people can quickly experiment on their data set and see how valuable their data set is. So the whole process starts with, of course, selecting a data set, then trying to do some sort of uh, massaging of that data. Uh, After that, you want to do feature engineering around it, select the right features, and then it goes through the steps of doing a train test split, automated training, and then based on that training, you want to know that which is your model based on the criteria that you defined has performed well. And then based on that, you select your model, and this also includes automated hyperparameter tuning, because you want to tune those parameters, different parameters, and see which is the best hyperparameter um, set, which gave you the requisite performance or accuracy that you were trying to see in your model. So that is what is AutoML. Now, AutoML solves two key pain points for data scientists. So of course, data scientists can do machine learning from first principles as well. But then where AutoML helps is that, one, you can quickly verify the predictive power of your data set. So you just push your data set inside this entire engine, and then you get to know how powerful your data set is. Whether, let's say, for example, this data set can actually predict whether a customer will churn or not. And when you do that exercise, in the end of that, what you get is a good baseline model which can guide your project direction. So you can take that baseline model as your template, improvise it, work through it, and then maybe come up with a better machine learning model based on that baseline model. So this, in a way, gives you a direction. It also gives you a benchmark uh, with which you can work and improvise your further experimentation around your data set as you try to develop more machine learning models around that. And the problems with exist with the current AutoML solutions, and where we are trying to help, is that the production cliff exists where data scientists need to modify the returned best model using their domain expertise just before the deployment, right? And data scientists need to be able to explain how they trained a model for further auditing or regulatory purposes, etc. And most of the existing AutoML solutions, they turn out to be opaque boxes. What that means is that you really cannot see under the hood what went to come up with that best model, how the hyperparameters were tuned, how much experimentation was done, or in all the runs which were done in order to come up with that best model. how your different metrics that you want to see had worked. So it's basically just a opaque box. And now where we as Databricks come into play and how we help is that the best model returned is, you know, often not good enough. So what we give is, instead of a opaque solution, we give a glass box solution in which the users get to see the full experimentation cycle which went under the hood when the AutoML experimentation was running, as well as we return or we generate and make it available the entire code for the model or the experimentation phase. So, what that means is that ours is a glass box solution. So, what we do is that we give a user interface, or you could use a API as well to start your AutoML training. You supply that engine your training data set, and then on click of a button, the AutoML engine runs in the background. It executes all the experimentation based on the parameters that you provide. And in the end of it, it returns these two nice notebooks. One, which you can use for further data exploration. It is like a good starting point. And the second one is a reproducible trial notebook, which has the entire code generated, starting with how it has modified your data or made it or done feature engineering, how it did the train test split. And then under the hood, we try to use some optimal libraries like HyperOpt for hyperparameter tuning. So you can see how that objective function was defined, how that run can be done, etc. And also, these notebooks have feature for you to turn on explainability or SHAP analysis. So that actually helps you trying to work out the feature importance as well. So all of this is returned to you as a glass box solution, and that's where our value add comes into play. The other thing I want to highlight over here is that, um, as you're aware, we have Unity Catalog, which is our governance layer, not just for your data or your tables, but also for your models. So in the end of this cycle, you can easily deploy your model into Unity Catalog, and then start drawing inference either in batch mode, or in case you want to serve in real-time mode, you could do that as well. Uh, at the end of the cycle, you would also understand and be able to debug the data quality. You can also see whatever pre-processing was done, and then iterate further as needed based on what output you see out of the AutoML runs. So how does Databricks AutoML work? So few key things I want to highlight over here, and then of course we will see it when I show you a demo as well. So first things first. So first is, it helps prepare the data set for model training. For example, if it detects some imbalances in your data, then it helps with, it carries out trying to fix those or reduce the imbalance in your data. So that is just one example of how it tries to prepare the data. It helps with hyperparameter tuning. It uses the HyperOpt library under the hood. You can iterate, train, tune multiple models, and it automatically distributes hyperparameter tuning trials across the worker nodes of your cluster, and it optimizes that whole cycle. And it also samples your data set, and if it is too large to fit into the memory of a single worker node, then it takes actions depending upon that. It evaluates your models based on algorithms from scikit-learn, XGBoost, LightGBM, Prophet, and ARIMA. based on what exactly you are trying to do. And my next slide would show you that for each of these three categories, classification, regression, and forecasting, which libraries we support. And based on this evaluation, as I was earlier also saying, it will return you the best model with the code which you can work through. The algorithms that we support over here, and all of these are have links, so you can explore those libraries as supported by AutoML. But for classification, for example, we support all these algorithms, decision trees from scikit-learn, random forest, logistic regression, XGBoost, LightGBM. Similarly for regression as well. Specifically for forecasting, currently what is supported is Prophet and the AutoArima library. Okay, so with that, now what I would like to do is I would like to take you through our workspace, and I would like to show you how this entire process works. So what you see over here, this is, as you are familiar with, this is our workspace. And what I have done is that I have tried to prepare a data set uh, which we can use and which we will see how you can do experimentation with it. So let's first see what the data set looks like. So I have already ingested the data. So as you're familiar with, and we will not go deeper into the details of how delta live tables work, but then I had a delta live table which pipeline which worked in the background, and I have brought in the data which we will use for our machine learning experimentation. So this particular data set has some customer data. Uh, as you can see over here, we have all these features: first name, last name, address, country, gender, age group, etc., etc. And then what we want to predict out of this data set is whether that particular customer would churn or not. So this is a classic case of a classification machine learning problem, which we would try to solve over here. Now, if you do little bit more exploration on this particular data, you can see some Seaborn based charts and see how your data layout is. Um, but what I want to highlight over here is that you can do further processing on this data set. You can use our optimized libraries like Pandas API. For here, for example, what I'm trying to do is I'm trying to drop columns, a few of those which may not be needed. But the intent eventually is to be able to create a feature store table. So the step so far, what I have shown you is that uh, I brought in the data, customer churn prediction data set into my Unity catalog. Next, what I want to do is create a feature store table, which I would use for my experimentation. So this is how you create a feature store table. You have these standard APIs which are available. You use this feature store client and specify which Unity catalog or schema you want your features to reside in. And then just with this create table API call, you can create the feature store. Uh, and I would show that to you inside the Unity catalog as well. So I have my catalog with the name as Jyotsna catalog over here. If you see, I have a schema C360 over here. As you all know, our Unity catalog is a governance layer, uh, and it not only has capabilities of addressing the cataloging of tables, but then you have models and volumes as well. So we will talk about all of that in a bit. But if you see over here, I have my churn user features. This is a feature table which I'm going to use for my AutoML experimentation that is ready for us to use. Right. So now let's see how do you actually create a experiment? So in this workspace, under the machine learning tab, you see the option for experimentation. You click over here, uh, create AutoML experimentation. So the first step that you need to do is, of course, choose a cluster. This cluster needs to have a ML runtime as well as Unity catalog enabled, since we would be interacting with Unity catalog. The next thing that you do is that you choose what kind of problem you're trying to solve, whether it is classification, regression, or forecasting. And now let's see how the options change based on the problem type that I'm trying to select over here. So let's say first I select classification over here. Now I would go over here. I would choose my data set. So as I showed you, I already have a catalog. It has a schema over here. I have this feature table, which I have already kept ready. So let me select this and let's see what it shows. So the next thing for a classification problem I do is select my prediction target, which is, of course, I'm trying to predict whether the customer would churn or not, or whether the user would churn or not. So I select that. What do I see over here? I see all these features over here. It also gives me an option of impute with. So what does that mean? So what AutoML automatically does is that in case it sees these null values in your table, based on the option that you select over here, it will try to fill in those values. So for example, in case of string, you could choose either most frequent or constant. In case of integer or in data type, you could choose whether you want it to be filled with a mean, medium, most frequent, or constant, and so on and so forth, right? So you can configure all of that, comes really handy. There are a few more advanced configuration over here which are available. So when you would be doing this experimentation run, you have to specify what is it that you want your best model to be evaluated on. And here are these different metrics which are available from which you can choose. So to a data scientist, all of these are very familiar, whether you want to evaluate based on accuracy, F1 score, log loss, precision, recall, or ROCOC, right? By default, it uses F1 score and it would log all these metrics, whether you specify any one of these for your evaluation, but all of these metrics would be logged for you to uh, be able to access them. And then you can decide on which training frameworks you want. You can specify a timeout as well. And this particular column, time column, for training validation split, you can choose that as well, a positive label. And then this is around, data storage location. Another feature which I want to highlight over here is that you can also join features. This is of course optional, but then you can join these features to another feature table, which is there inside Unity catalog. So in my catalog, for example, I created this another table, customer demographics, and it's just for demo sake. And let's say, because this is assuming a telecom customer data set, I again have a user ID primary key, and let's say usage of that customer. So the way I would join this table to my actual features is based on user ID. So I could use that to join. So all I need to do is select my catalog over here, and then the feature table I want to join on. So this is also a feature which is available in case you want to join features. Okay, so this was classification. These are the options which I see for classification. What do I see for regression? So the options are almost similar. You choose a data set and prediction target, name of experiment, etc. But then what also changes over here is the metrics on which you would try to evaluate that particular experiment on. Similarly, if you would choose, let's say, forecasting, then again, the options change, because for forecasting, you would need a time column to be specified, and also time series identifiers in case you're doing multi-series forecasting. And again, the metrics on which you want to evaluate it, they also change, the default being SMAPI. And the training frameworks, which I earlier mentioned, these are the ones, RIMA and Prophet, which we are using. So now, since ours was a classification problem, let me just go back over here and let's choose this. And then all I need to do is just click on this start AutoML, and it will start doing what it needs to do, which is experimentation, right? So it will start this experimentation and start working in background. So um, in interest of time, what I have done is that I already ran one such experimentation. So I would show that to you. So if you see over here, this is AutoML DSB. So let's open it up and see what do we have over here. So if you see over here at the bottom, uh, so let's see this part first. Let's try to understand this. So AutoML DSB, this is my classification machine learning experimentation, which I ran with the data set, which I just showed you. And what it did was it ran all this experimentation for me. And at the end of this, what it told me was that my best notebook based on the F1 score, or my best model, is inside this notebook. And it has also created this data exploration notebook, right? The other thing, what it has done is that, let's see all of this. So let me add all of these matrices. So as you can see, even though, as I was saying, we had specified that it should be using F1 score for evaluation, and that's what it has actually used. If you see over here, it has logged all of these other metrics as well, which you can use the way you want to. And it has done it for all: train, test, validation, all three splits which it has created. Right. Now, what you can do with all of this is, let me collapse this a bit. With all this experimentation, these are all features based on our MLflow, MLOps engine. You can see all these matrices. You can basically choose which experiments you want to compare them. You can create additional charts in case you want for comparison based on these different parameters, right? So you can do all of that. Let's also open one of these experiments and see what is there inside it. So it has all these details. It tells you which data set it used, what was the source. So we will in a bit see that source as well. Uh, you get to see all these different parameter metrics as well over here. Besides that, a lot of logging is also going on. AutoML does that automatically. Um, and it has also created all these different nice charts for data exploration, confusion matrix, and precision recall curve, etc., which also help you understand how your data is progressing as far as training, your training set and test set and your validation set are concerned. And besides that, these are your standard things which will help you um, promote this particular model from one environment to another. You have all these YAML files, etc. Right? Okay. So now let's go back to our AutoML and let's see what notebook it generated for us. So let's open this data exploration one first, and let's see what it has generated. So in this data exploration notebook, this is basically to help you understand the power of your data. So This is a template it generates. You can play around with it in case you want to make changes to it. And it is basically giving you a profile report of your data, which you can use to further understand what you can do with your data. Right? So you can see all these nice charts for different features which have been generated and which help you understand the distribution of data uh, for each one of these features. So for example, age group, how many were distinct, what is that percentage, how much was missing, what is the mean distribution, how many zeros, negative, memory size, etc. Pretty useful, right? For us to further work on our data set. So yeah. The other thing it did was that it also gave me this notebook in which I can see what it considers to be the best model based on the hyperparameter tuning that it did. So according to it, this light GBM classifier gave the best results. As you can see over here, it is also doing imputation on few of these columns or features. So for example, for numerical columns, it has used mean. For categorical columns, it has used low cardinality categoricals. Next, what it has done is that it did a train test validation split over here, 60-20-20. Um, After that, as I was saying, um, uh, AutoML uses hyperopt. So this is where you have the objective function, which the trial runs would try to minimize and come up with that best combination of hyperparameters. So this is how you configure your hyperparameter search space. So based on these hyperparameters, it will run the trials. So as you know, it uses this trials, Spark trials. HyperOpt is a library which is part of our machine learning runtime. So that is what it uses to parallelize the entire training process and to speed it up. Um, After that, so yeah, then it gives you this particular method for logging it. And another interesting thing, as I was talking about, it also enables or gives you a template for doing SHAP analysis on feature importance. So by default, this flag over here is false because in general, it takes a while to generate the Shapley analysis, but I just turned it on to true just to show you how it generates this SHAP analysis. So if you see over here, it generates this plot and you can see um, the based on the feature value, which are the ones which are of higher importance around age group, event count, maybe gender as well, right? So it gives you a lot of insight on your data set itself, which is extremely useful. And all of this, it has auto-generated, right? So I did not have to write even single line of code over here. Um, it also um, gives you a template of how you want to register the model. So we will talk about that as well in a bit. But then again, few more charts over here on how the training run went and how the model performed as far as on these different curves like precision recall, or let's say ROCOC as well. So this is what it has done for me so far. So now, um, let's say, for example, I like, for example, this particular model, right? And okay, this is already registered. So let me choose something else. Let's choose this one. I just want to show you how to, register the model. So now I have my experimentation done. I know which is a good run, which I want to use as a model. So what do I do next? So um, you have this option of registering this particular run into model registry or into Unity catalog. So just FYI, we are moving in the direction of having everything under Unity catalog. So it is recommended to follow that approach because eventually model registry would get phased out. So so if you see over here, it gives you a code snippet to use to register your model to Unity catalog. So let me open a notebook in which I was trying to do that. So yeah, this is the one. So what do I have to do to register my model to Unity catalog? So I have my catalog, I have my schema, I have my model name, and the most important thing is this run. So this is something which you can actually see from over here. This is my run ID, which I am trying to uh, use to register my model. And that is it. So once you run this, your model gets registered into your Unity catalog. And this is how you can see it over here under this catalog schema. And it logs different versions over here so that you can track everything and you can start using that model or serving that model from over here itself for inference. So that's the next thing that we will see. So far, just to summarize what we saw is that we ran a AutoML experiment on my churn data set in which we were trying to predict whether a customer would churn or not. We ran that experimentation, and out of that entire experimentation set in which I saw a number of runs, I chose one of those runs and I said, okay, I like that. So I tried to move that into my Unity catalog as my model. So I now have my model, which is available for me, on which I can use for my inference. Now, inference also, there are two ways in which you can run your inference. One is batch mode, or you could also use real-time model serving. So let's first see the batch mode and how do you go about doing that. So over here, you can see one example of doing batch inference. So what I am doing over here is that I am scaling the inference using Spark. So I created a UDF. I created a Spark UDF over here, as you can see over here, which uses my model and with the alias as well. So alias you can define as part of your model definition inside Unity catalog. So I'm using that to get my model. I define a Spark UDF, and after that, all I need to do is that I invoke that particular user defined function over my data set, and it will write to the table. It will predict the results for me. As you can see over here, this is the column which is added over here. So this is the prediction for this particular data set using my model in batch inference, right? So this is the example of batch inference. Now let's talk about real-time inference as well. So as I was just showing you, this is my model over here inside Unity catalog, and you can serve this model from here itself. So let me just click this and it will take me to a page where we will try and define our endpoint, serving endpoint for real-time inference. So let me just call it as DSP churn and point, right? Now, um, since I invoke this particular endpoint from my model itself, so it is already showing me which model I can still choose which version I want to use. Since this is a simple classification problem, I'll just maybe choose a CPU based small, so I can just choose CPU over here. What I want, what I can also choose is whether I want to um, log the payload being generated as part of this real-time serving to a inference table. So I can choose my catalog, again my schema, and then define a prefix, whatever I want, let's say DSB or whatever I want, and then on click of a button, it will start creating a endpoint for me, right? So it will start creating an endpoint using which I can do real-time inference. So while it creates this, I think I might have one which I had created earlier. So this is the one. So if you see over here, this is test model serving. As you can see, I had associated a inference table with it. So this inference table is over here. So every time I would invoke this particular endpoint, it would log the request and response in this particular table, which you can further use for your monitoring, etc. So now once this endpoint is ready, how do you basically use it, right? So here, for example, it does give you a example uh, how you could use it for inference, but you have APIs available, so you could use that. So I used the user interface to create that endpoint, but then you can also use APIs to do that, to register your endpoint using APIs as well. And this is how you score your model using that particular endpoint. This is a small code snippet which shows you how you can invoke that particular REST-based endpoint and then score your model using that. Right? So isn't it amazing? Without writing much code, I could actually do a end-to-end cycle. Created, I did experimentation. I was able to see how powerful my data set was. I was also able to see and explore that particular data set. And in the end of it, quickly I could register that model. And now I know how to use that particular model either to do batch inference or real-time inference using our infrastructure, right? So these are the few things which I wanted to share on AutoML experimentation and how to use that inside our tool. Happy to address any questions which you might have. This recording, of course, would be shared with all of you. Uh, so yeah, I will stop sharing over here. Hope you found this useful. All right. If there are no more questions, then maybe we can stop the recording over here, and then you can always reach out to me for any further questions, clarifications, etc. Thank you, everyone. Thanks. Bye.